Okay, a reminder from the last session, we looked at the what? The first special register. We said it's the what? It's the circulating register. What did we say? We say that we can either choose new data. If we have 0 here, 0 blocks circulating data. This is circulating data, probably. It would be nice to indicate that circulating data. So a 0 is blocking circulating data. It's allowing new data to what? To be fed, because a 0 would be a 1 there. It will be a 0 here which ignores that input, automatically drives this to a 1. Okay, and then that 0 will be a 1 there, allowing us to know what data is. If it's 0, that 0 changes that to a 1. 1 1 gives us that 0. Okay, and then if it's a what? If it's 1, that data is 1 there. 1 1 will give us 0, and that 0, that 1 has been allowed to go through. All right, otherwise what happens is that you what? Otherwise you have a 1 which says let's circulate. 1 would say 0 here. 0 says I don't wait for you. It blocks and says I'm here. Let's say now you're circulating data, or you're circulating a 0, then that 0 will change this to a 1. 1 1, your 0 circulating 0 would have come through. Okay, or now if you were circulating a 1, okay, that there is what? 1 1, that would be a 0. The moment you have a 0, don't care about the other side, that will be a 1. Your circulating 1 has come through. So that is what calls a refresher from the previous situation. But now also another thing that we need to remind people of is that we could have used, instead of the inverter there, we could have used any one of the what? The options that can give us the what? That could have given us an inverter. Now let's not eat too much time into our what? Our other register. Our other register that we want to look at is obviously the ring counter. With the ring counter, let's say I have my what? My let's rather do what? 4-bit or 5-bit, doesn't matter. Let me do 5-bit so that I can explain something. This is a 5-bit version of the ring counter. There's our output as a Q. If it's 5-bit, 2 to the power of 4 is 16. This is obviously working as a shift register, so they are configured as D's. All right, so this here is what? Going to be our Q8, and then obviously it's another D, Q4. Let me move a little bit faster. I think people know what's going on here. Q2 and Q1. Now obviously the operator is D's, so if it's not D types, if it's D types, something else would happen. If it's not D types, then what you have? You don't worry about the what? The not Q. Q, 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 Q. Okay. However, for the ring tab, what am I doing? Oh, wrong side. Okay. Wrong side. Oh, we're there. Okay. The Q's are there. Okay. So let's use, even if it's SR, it would work. But I'll stick to JK because I hate mixing them. in case of other parameter differences. Okay, I hate mixing them in case of other parameter differences like speed and whatever. So I'll have to mix, because you can find that if you're not careful, if they don't operate the same clock speeds and whatever, it might complicate matters. So I'm doing the trailing edge one. Okay, it's a little tricky to do the little arrow. Okay, it's a shift register, so obviously the clock is common. So now one would suggest that probably we have to make this a T-type. No, not for this counter. This one does not have to be. So I said I didn't want to mix, because I could have used any other one, because the other ones I could have, if I used SR, I would have but this is specifically with the what this one needs to do here is specific to to a JK. So we can't do whatever we like now. So what I'll then do is, this has to be JK, so therefore I have to do all of them as JK in case of clock speed, clock and other characteristic characteristic variations, differences. So what I'll then do is, I'll say what you need to do with the Johnson is that every one that is in between this one here must feed back. That one there, the not Q, I didn't say not Q, I only did with the last one. The not Q's of the other ones must feed back. Oh God. Doesn't matter, I can't really fuss. All I need is three of them, the three of them too. No. It's gonna take me longer than I want this now. All I want is that the three of them must feed back. So the last one must also feed back. The mid ones must feed back. The mid ones must feed back. So this one is 1, 2, 3. I am mid. The first one and the last one, no. 1, 2, 3 must feed back. Okay, the last one, no. So what then happens is that when you've got something like this now, let's say your flip-flop was on, let's look at the operation now. What does this mean here? It means this will operate as if there was there was an AND gate. Sometimes you could just replace this with with an AND gate. Let me just do this. Instead of doing this, you could also simply have 1J and place an AND gate. Okay, and place an AND gate, and those three be fed back via the AND gate. It means the same thing there. Okay, note that the K is not is not wired. So what we then do, let's look at the operation. Let's say there is a clock, and I don't want it to be, let me possibly move this first out of the way. Okay, let me move this a little bit up out of the way, and then I will then hopefully have enough space. So this is our clock. I didn't indicate the clock there. I'm not happy with my clock there because it's now but there's no connection there, so I can go ahead and say clock right there. And as you can see, it's a shift register, so it's synchronous. So there's the clock. Let's have the input. Let's say 1, 2, 3. We're doing number 3. 6 ne. I'm not sure now, I've lost count. Oh, okay, let's just number them. 1 2 3 4 5 6 7 8 9. Let me have a couple more. This is the timing diagram that will show us how this works. 10 11 and let's make it damn a dozen. 11 12. Okay, so now forgive me, they're not the same, they're actually things a little bit tough. Now what I want to do is I want to have I don't want to reset anything. I just want to I don't want to set and reset anything here. I just want to I want to see how the thing can autocorrect itself even if there was an issue. So what I'm going to do is I'm going to say Q1, Q2, Q3, Q4. Oh, what am I doing? I'm now just counting in my head. I'm no longer thinking what I'm doing here. Okay, this is Q1, Q2, Q4, Q8, and Q16. Okay, probably let's say we started off with this one on a what? On a 1. Remember, it's reacting to the what? The flip-flops open at what? At the trailing edge. So I'd like to mark this. It will take a while. There's a lot of cycles here. I wish I could just use a ruler. There is an instrument. I just don't want to take time looking for things. Well, one would argue that we're taking time already, but yeah, I would say you are right. Say if you want to know the best way not to argue with a fool, you just say, you are right. So if someone says, but you're wasting time already, I say, you're right. Okay, so now let's just quickly try to be quicker, and it's a lot more, or maybe I'll throw it out as I need. No, but it's fine, I'm almost finished. So I just need these as guides as to where I expect changes to mark my clock pulses. Okay, this is all just okay. There is our last edge there. Alright, so I'll leave that one hanging. Now let's suppose that one there is started off as a what? As a 1. Q1 had been a 1. Let's say Q2 had been a 0. Q4 another 1. Starting off a default count. Let's say 0 and another 1. Let's say that's where they started. Now if you observe here, okay, if this is 1, Q1 is 1, and that is 0, that's 1, that's 0, and that's 1. Okay, this when we open, when the clock edge comes there, the trailing edge, it's a master slave. So when the edge comes, all the data that's waiting, that one is fed there, that one is fed there, that one is fed there, and that one is fed there. Okay, what is fed back? Obviously this is 0. So the moment there is 0, I don't even have to, no, this is 0, the output is 0, that's a 1. Okay, that there is a what? Is a 1, so this must be 0. So the moment I see 1 0, a 0 will go through, because an AND gate, once it sees a 0 is waiting. So when the edge arrives, whatever is on Q8 is goes to 16. So Q8 becomes 0. Q16, sorry. becomes 0. Okay, this came to 16. Okay, that one goes there. Q8 becomes 1. Okay, so this 0 was fed there. Q4 becomes 0. That one is fed there, so Q1 becomes 1. Q2, sorry, becomes 1. And a 0 was fed to Q1, and that becomes 0. Okay, now that we have this, okay, now that we have this, what happens now? We look at the next edge. At the next edge now, Q8, which is a 1, is fed through to that. That becomes, Q16 becomes 1. Q4 becomes Q8, becomes 0. 8 becomes 0. Q2 became what? Q2 became Q4 becomes 1. And Q1 became Q2, which is 0. And what was waiting, I didn't study what was waiting before. Let's see what was waiting to go to Q1. This was Q2 was a 1, so that 1 would have given us 0, so we still have a 0 waiting, so this stays a 0. I should have made that study first. So now what do we have? 1 0 1 0 0 1 0 1 0 0. Okay, so because of this 1, we still have a what? A 0 being fed back, so that one is fine. Next pass, we have that 0 going through to 16. 16 becomes 0. Okay, that 1 coming through, Q8 becomes 1. And then that 0 coming through, Q4 becomes 0. And then that 0 came through to Q4, and then that 0 still came through there. Q1 became Q2, and Q2 became 0, was already 0, stayed as 0. And that 0 was fed back, and okay. What then happens next is we have 0 1 3 0 0 1 3 zeros. That 1 there makes this a 0, and still we have a 0 there. What then happens is that next pass, that 1 goes to Q16, and Q16 becomes a 1. Just said 1. And then that Q4 becomes Q8, Q8 becomes a 0. And then Q2 becomes Q4, Q4 is a 0, so Q4 stays a 0. Q1 becomes Q2, 0. And the 0 that was waiting there is passed through. Now, what do you notice? I forgot to mention here that if we've mentioned before that if a JK is not wired, it sees it as a 1. So what we've been having so far, every time we had 0 here, this has been a 0 1 0 1. So it's been acting like a what? Like a D-type. But remember, this is a versatile one. When the two inputs are not the same, it acts like a what? As if there was an inverter there. So it acts like a D-type. So it's been passing the 0 through simply because that was a what? That was a 1. Alright, that is very important to mention. Now what do we have? We have 1 with zeros there. All right, so there is nothing there that can what? There is nothing there that is a 0. So now certainly this becomes a 1. So the input that is waiting there now is a 1. Why? There is no 0, so all of the Q's are Q2 to Q8. The in-between Q's are what? Are zeros, so these ones, the not Q's, are all ones. Suddenly the AND gate gives us a what? Gives us a 1. Now, if I may clean this up because it's becoming messy, we'll remember them because they're all down there. We'll write them again, but I don't have to remove that one. Only Q1 was a, only Q16 was a 1, the rest were zeros. Okay, what happens next now? What happens next is that 1 there was supposed to be lost, but is it lost? So Q8 comes in there, so this becomes 0. So is our 1 lost? Let's see. Okay, then Q4 became that, it's a 0. As you can see, Q2 became Q4, 0. And Q1 became Q2, 0. Now here we have 1, but remember this behaves like a 1. Okay, so it's 1, 1. 1, 1 means toggle. Toggle means change from whatever state. This was a 0, it becomes a 1. So that one there becomes a 1. Okay, now that we have a 1 on what? On Q1, so Q1 becomes a 1. Okay, because of the toggling. But we still have these 3 guys being zeros, so these 3 guys are still 1s, so that one stays there. So we still have 1, and not worrying means 1, so it's 1, 1 again. So this is going to toggle again. All right, let's go ahead and see what happens now. This Q8 becomes that, so this becomes 0. Q8 is a 0, so Q16 follows 0. Okay, and then Q4 becomes Q8, 0. Okay, Q2 becomes Q4, 0. Q1 becomes Q2, 1. And was that going to be 1? No, this is going to toggle because it's 1, 1 again. So this toggles to 0. So that is a 0. Okay, what do we have now? We have that being a 1. So I'll check what this is. That being a 1. The moment that's a 1, we feed back a 0. And it's like we've got 0, 1, because remember this is not what, it's like a 1. So it's like a D type, so this 0 will go through. So let's see what happens now. Q8 becomes what? Q8 becomes 0 from, becomes Q16, 0. Q4 to Q8, 0, 0. Q2 to Q4, Q2 was a 1, so 1. Q1 to Q2, 0. And 0 is fed because this is 0, 1. 0 is fed to the first one, and it's a 0. All right. So when you look at the next one, again we've got a 1 here. What we have now? Q4 is a 1. Okay, Q4, I didn't write it there, just said it. Q4 is now the only 1. Okay. All right. So what happens now is that Q8 goes on to make Q16 0. That one, Q4 to Q1, it's a 1. Q2 to Q4, that's 0. and Q1 to Q2, that's 0. But that one they had made this one here what? A 0. So that 0 comes through because it's 0, 1. That's a 0. Okay. Now, when you look at the next one there, what's going to happen now? We have the 1 on Q8. So this one moved. We said it. We didn't do it here. It makes us a little bit slower. The 1 is here. So what does it mean? We still have 0 on the node Q of Q8 and 0 still stays there. It's still 0, 1 because no connection means 1. So what happens now is that for the next one here, if you look nicely to be faster, that 1 came there, that 0 came there, that 1 came there, that 0 came there. That 0 came there, that 1 came there, that 0 came there, that 1 came there. That 0 came there, that 1 came there. It's not good to say that 0 came there though, but yeah, that 0 came there, that 1 came there, that 1 came there, this one came there. So they've been sliding. That 0 is sliding with each pulse. That 1 is sliding with each pulse. That 0 is sliding with each pulse. That 1 is sliding with each pulse. That 0 is sliding with each pulse. That 1, well, gets lost. The last ones keep getting lost. So you can see this is 0 sliding. So I can simply say that there is going to be 0. That 0 is going to come there. No. That 0 is going to be fed through 0. This is from the new data. It's fed through. Q1 has got nothing to do with its new data. It's fed through. But that is 0 is fed to the other one. This 0 is fed there. That 0 is fed there. That 0 is fed there. That 1 is fed there. Okay. So what happened now is that we have 1, 0, 0, 0, and 0. Now, what happens now is when we've got zeros again here, so everything is zeros here. These 3 in the middle as all zeros, that goes back to, and you can see the cycles repeating. That goes back to 1. 1, 1 means what? 1, 1 means toggle. So we are back to that situation there with what? With 6. 1, 1 there means toggle. So this one will toggle to a 1. Otherwise, the rest will slide through. That one slide through. That one slide through. That one slide through. The other one is obviously lost. So I really don't need to. This is taking us the whole day. There is no need for us to do this other cycle here. I will end it right there. My point has been made. Now I want to explain what you've been, in case people are not aware what you've been doing here, what has been happening. I will just take the time now to look at that. Okay, if you look at this now, the register started off with what? With more than 1, 1. It kept clearing the ones. Okay, probably there's still 2 here, still clearing. It took 1, 2, 3, 4 steps to clear. I would argue that it took actually what? 3 steps to to clear that. On the 4th one, it is already where we want. If you can highlight this and say at that point then, it has already achieved what we want. This register will start off, if it starts off with more than 1, 1, it will clear out until it has only 1, 1. Now it will start circulating that one. Now this one, there was only 1, 1 here. The 1, 1 came to the highest, went to the lowest, went to the second, went to the third, went to the fourth, went to the highest, starts again, and the cycle repeats. So what does the ring do? The ring register, the ring counter, sorry. The ring counter clears the register. Ring counter, we are talking about ring counter here. Oh, by the way, in case these 3 are going to confuse, this is the ring counter. Okay, clears the register of all but 1 digit 1. Let me rather use the word 1 1 1. Okay, then circulates this digit with each cycle. Okay, so basically what it does is, if we had more than 1 ones, it will clear them all, which is correction. It took 3 cycles to correct here. When it has 1 1 left, it starts circulating that one. It starts circulating between the what? Between the what call this, the flip-flops. Okay, so that's what the ring counter does. Next we meet, I'm going to look at the Johnson counter. The ring counter is a special counter. We started off with the circulating one. Now we are doing the what? The ring counter, and I hope it was not as complex as it, well, it is not that complex. Let me rather make it that simple. So see you when we do the next one, which is what? Which is our Johnson counter. And I think I will end there with the shift registers. Thank you.